Welcome to section 5.1. We'll be discussing angles in this section. This is going to set us up with some very basic terminology that we'll be using. A lot of it comes from geometry, so some of this is probably familiar to you in this first section. We start with the discussion of a line AB. It's just simply a line drawn through 2 points AB. It's got arrows on both ends. A line segment is like a line, only it's got a beginning and an ending point, so you used to notice that there are no arrows on the line segment. On ray AB, that's got a starting point, and then it continues forever and passing through point B. An angle consists of two rays with a common endpoint. These two rays are the sides of the angle, and the common endpoint is the vertex. So here we can see we would call this angle A, and its vertex is at point A. It's formed by two rays. The measure of an angle is generated by a rotation about the vertex. So again, here's my vertex, and if I imagine, look at this we call this the initial side, and then this is the terminal side. So if I place my pen over the initial side, I'm just making a rotation around the vertex up about this far to get my terminal side. And of course I could keep going to make a different angle. This measure is determined by rotating a ray starting at one side, called the initial side, to the position of the other side, called the terminal side. Okay, if we go to page 2. A counterclockwise rotation, meaning that you're going in this direction, like this, gives a positive measure. So that's very important. You'll need to remember that the counterclockwise rotation gives us a positive measure. A clockwise rotation, like if we start at the vertex and we go this direction, will always give us a negative measure. So in this picture, I've drawn, it looks like the same angle, but in the first one, starting at my initial side here, I'm going counterclockwise, so I have a positive angle. On the right side, starting at the initial side, if I go in the clockwise direction, then I have the negative angle. So even though these two look the same, there's two different ways to think about it. The most common unit for measuring angles is the degree. In degree measure, we assign 360 degrees to a complete rotation of a ray. So you know from geometry that the circle has 360 degrees. Same idea here. Here, acute angles would measure between 0 and 90 degrees. A right angle measures exactly 90 degrees, and of course it's going to have this little square to indicate it's a 90-degree angle. Obtuse angles measure between 90 and 180 degrees. And straight angles measure 180 degrees. So with a straight angle, you're starting here and you're just going over here, and you can think of this as a straight line. So the 180 degree angle is the same thing as a straight line. All right, on page 3. We often use the Greek letter theta to name an angle. If the sum of the measures of two positive angles is 90 degrees, the angles are complementary, and the angles are complements of each other. So two complementary angles, if you put them side by side, so let's say I've got this angle, it might be 45 degrees maybe, and then maybe I take a new angle, and so it's going to go here and then go like this. The two angles together, if they're complementary, create a 90-degree angle. Two positive angles with measures whose sum is 180 degrees are supplementary, and the angles are supplements of each other. So two supplementary angles, when they're put together, would always create a straight line. So maybe you've got one that looks like this, and then maybe your second one is going to join the first one. The two together create this 180-degree angle. In example 1, we're asked to find the measure of the complement and the supplement of an angle measuring 40 degrees. So for part A, when I do the complement, remember complement means that the two angles together need to add up to 90 degrees. If my angle is 40 degrees, I need to do 90 degrees minus 40 degrees, and the complement is going to give me an angle of 50 degrees. In part B, find the supplement of the same angle measuring 40 degrees. The supplement, the two angles added together the supplement and the original angle are going to add up to 180. So I can do 180 degrees minus 40 degrees. So my supplement is going to be 140 degrees. In example 2, find the measure of each marked angle. So looking at the two angles, you'll see that together they form this 90-degree angle, as indicated by this little square here. So that tells me that these two angles, when added together, are going to give me 90 degrees. So I can set this up as 6x plus 3x equals 90. And then a little algebra, I get 9x equals 90. Divide by 9, x equals 10. So if x equals 10, then that means that the first angle is 6 times 10, or 60 degrees. And my second angle, 3 times 10, is going to be 30 degrees. Does it make sense for those? Does that make sense? Well, yes, 60 and 30 does add to give me 90. So that should be right. In part B, we have a similar situation. Part B, we're going to find the, how did they say it? Find the measure of each marked angle. So this time I've got these two angles. They create, these are supplementary angles because they create a 180-degree angle. So we're going to add 4x plus 6x and set that equal to 180. We can add these. That gives me 10x equals 180. Divide both sides by 10. I get x equals 18. So my first angle is going to be 4 times 18. How much is 4 times 18? That gives me 72 degrees for the first one. And then my second one is going to be 6 times 18. So that's 108 degrees. So 72 degrees and 108 degrees, and of course these should be adding together to give us 180, and they do. Okay, here's some more. These are some units that we need to be aware of. 1 minute, written 1 with a little tick mark like this, is 1/60th of a degree. So we can say that 1 minute is equal to 1/60th of a degree, or it's also true that 60 minutes is equal to 1 degree. Then the second unit that we need is the second. 1 second, and this time you've got a little double tick mark, is 1/60th of a minute. So we can say that 1 second is equal to 1/60th of a minute, and it's also equal to 1/3600th of a degree. Or you could also say that 60 minutes equals 1 second. I'm sorry, I need to rephrase that. You could also say that 60 seconds equals 1 minute, and 3600 seconds equals 1 degree. So all of these are conversions that can be used. In example 3, we are asked to perform the calculation. We need to add 51 degrees 29 minutes and 32 degrees 46 minutes. So I'm going to set this up as an addition problem, and I'm going to do it vertically. I'm going to line up my columns so that I've got degrees together and minutes together. So I need to do 51 degrees 29 minutes plus 32 degrees 46 minutes. And I can go ahead and add these together. 9 and 6, that's 15. So, and then that's going to give me 7, so 75 minutes. And then over here I've got 83 degrees. So adding these together is giving me 83 degrees, 75 minutes. But this is not in simplest form because we know that 1 degree is equal to 60 minutes, and here we have 75 minutes. So this 75 minutes is the same as 1 degree, and that would leave 15 minutes, just subtracting 75, and just subtracting 60 from 75 is going to give me 15 minutes left over. So it becomes 84 degrees, 15 minutes for my answer. Part B, we want to subtract 90 degrees minus 73 degrees, 12 minutes. Again, make sure that you're lining up your degrees and your minutes. Of course, the first one does not have minutes, and if we're going to subtract, you can see that we're going to need to borrow. We need something to subtract our 12 minutes from. So 90 degrees would be, you could also write that as 89 degrees and 1 minute, 89 degrees and 60 minutes. So we'll say 89 degrees, 60 minutes, minus 73 degrees, 12 minutes. Didn't mean for that to run together like that. Alright, so subtracting these, we have 60 minutes minus 12 minutes, that's 48 minutes. 89 minus 73 is going to give me 16. So 16 degrees and 48 minutes. And that is in simplest form because 48 minutes is less than 60 minutes. 16 degrees and 48 minutes. For example 4, we want to convert 74 degrees, 8 minutes, 14 seconds to decimal degrees to the nearest thousandth. So we're going to use those same conversions that we talked about a moment ago, those same units. To convert this, they're asking us to write it in decimal degrees to the nearest thousandth. So we're going to have 74 degrees plus 8 minutes would be 8 divided by 60. So if we divide our 8 minutes by 60, that will put it into degrees for us. Plus, and then the 14 seconds, we'll divide it by 3600. And we can type this directly into the calculator to get the decimal degrees. So I'm going to do 74 plus 8 over 60 plus 14 over 3600. And I'm getting 71.1372 degrees. Okay. Now, of course, if you have questions about any of this, do not hesitate to ask me in class. The structure of this course is set up so that there's as much opportunity as possible for you to ask questions. So, if there's anything in the notes that you're not getting, please feel free. Remember to just ask me about it in class, and I'll talk to you in more detail then. Part B. Convert. This is 34.817 degrees. We're going to convert this to degrees, minutes, and seconds to the nearest second. So we're going to start with, so the 34 is already in degrees. The 0.817 is in degrees and it needs to be converted into minutes. So we need to say 0.817 and multiply this by 60 to get it into degrees. That's giving me 49.02. So this is putting the 0.817 into seconds for me. So at this point, I can say that I've got 34 degrees, 49 minutes. I've actually got 49.02 minutes. But I need to get this into seconds. So this decimal portion needs to be converted into seconds. And to do that, I'm going to take the 0.02, okay, and I'll ask you, what do you think I should multiply this by? Remember, it's already in seconds. I just need to get it one step over into, it's currently in minutes, and I need to get it 1 unit beyond into seconds. So because I'm just going from minutes to seconds, I'm just going to multiply this by 60. 0.02 times 60 will give me 1.2. So now I can say that my answer is 34 degrees, 49 minutes, and 1.2 seconds. However, we were asked to round to the nearest second. So if I round to the nearest second, 1.2 needs to be rounded to 1. So I'm going to say that this is approximately equal 34 degrees, 49 minutes, and 1 second. And let's look at the next page. So more important terminology here. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So these are two examples of angles that we would consider to be in standard position. Their initial side, so their vertex needs to be at the origin. Their initial side or their starting side is going to be on the x-axis. An angle in standard position is said to lie in the quadrant in which its terminal side lies. So looking at my first example, my terminal side is here. Since this is in quadrant 1, then we would say that this angle is a quadrant 1 angle. My second example, my terminal side is over here, so this would be a quadrant 2 angle. Angles in standard position whose terminal sides lie on the x-axis or the y-axis, such as angles with measures 90 degrees, 180 degrees, 270 degrees. These are called quadrantal angles. So just a quick illustration. So you've got, here's your x-axis, here's your y-axis, and let's say that you've got an angle with initial side on the x-axis and terminal side all the way over here on the y-axis below 0. So let me get another color. I'll try to do this with another color. So this is my angle. Got my little boy's magic marker here. Okay, so that's where my angle appears. That's an example of a quadrantal angle because its terminal side is on the y-axis. Another one could look like this. For example, a straight angle. If you've got your initial side on the x-axis and terminal side is also sitting on the x-axis but on the other side, you've got this 180 degree angle. But because your terminal side is also on the x-axis, this is also considered a quadrantal angle. And the same thing with a right angle that's in standard position. That would also be considered a quadrantal angle. Coterminal angles. So here we need to, like we've got a little discussion on coterminal angles. A complete rotation of a ray results in an angle measuring 360 degrees. All right, so that just creates a circle. By continuing the rotation, angles of measure larger than 360 degrees can be produced. So in this illustration, we have an angle of 420 degrees. But it also looks just like a 60 degree angle. So the 60 degree angle starts from the initial side, and the 60 degree angle actually has terminal side here. The 420 degree angle starts on the x-axis. It follows the counterclockwise rotation all the way around back to the x-axis and then up an additional 60 degrees. So this would be the 360 degrees plus another 60 degrees gives us the 420 degree angle. So with coterminal angles, their measures differ by a multiple of 360 degrees. So in this example, the 60 degree angle and the 420 degree angle are coterminal angles. Their difference is 360 degrees full rotation. Example 5, we want to find the angle of least positive measure that is coterminal with each angle. Our first one, we have 908 degrees. All right, one way to think about this is to just subtract 360 as many times as you need to until you get the smallest number that's still positive. So if I take 908, subtract 360, I get 548. Let's subtract 360 again. I get 188. If I subtract 360 a third time, I'm going to go into the negative number. So my answer is going to be 188 degrees. That's 188 degrees. In part B, I'm starting with negative 75 degrees. I want the smallest positive coterminal angle with negative 75 degrees. So I'm going to start with negative 75. I'm going to add 360. That gives me 285. I don't need to go any higher than that because they want the smallest one. So 285. In part C, I've got negative 800. I want the smallest positive coterminal angle with negative 800, so add 360. Alright, I'm still in the negatives. I've got negative 440, so let's do it again. I've got negative 80. I'm still in the negatives, so I need to add 360 one more time. That gives me 280 degrees. That's the smallest positive coterminal angle with negative 800 degrees. Alright, now working with numbers that are relatively small, I'd say under 1,000 or above negative 1,000, adding 360 as many times as you need or subtracting 360 is going to be fine. However, if you've got a number that's really huge, like say 10,506, you might want to use the formula to help you find the coterminal angle. And here, this tells us that we can find angles coterminal with 60 degrees with the formula 60 degrees plus n times 360, where n is any integer. And there might be a time where you're asked to actually use this formula. Of course, I could say the same thing with a different degree. So let's say we're working with a 30-degree angle. We can find angles coterminal with 30 degrees by using the formula 30 degrees plus n times 360. So that just means that start with the degree that you're given, and you can add 360 times any integer, any whole number, to get you another coterminal angle. Alright, and then example 6 is the last one from section 5.1 that we're going to talk about in the video. A constant angular velocity disk drive spins at a constant speed. Suppose a disk makes 480 revolutions per minute. Through how many degrees will a point on the edge of the disk move in 2 seconds? So let's draw a picture. We've got this disk and we've got this angular speed. So here's the vertex or the center of the rotation. Alright, and this angle is just spinning around 480 revolutions per minute. Through how many degrees will a point on the edge of the disk, say let's say it's sitting right here, through how many degrees will this point pass in a time span of 2 seconds? So we're going to start by, we've got 480 revolutions per minute. Let's think about what's happening in 1 second. How many revolutions are occurring in 1 second if it's making 480 revolutions per minute? We can do a simple conversion to get this. So 480 revolutions per minute, so 1 minute, times, and then I can easily convert this into seconds just by I know that there is 1 minute has 60 seconds, and of course I set it up so that my minutes will cancel out. So crossing these out, I've got 480 revolutions per 60 seconds, but 480 and 60 can be reduced. 480 divided by 60 gives me 8. So I have 8 revolutions per second. Okay. Now we're being asked how many revolutions occur in, we're being asked how many degrees will it pass through in 2 seconds. So we know that it's 8 revolutions in 1 second, so that's going to mean 16 revolutions in 2 seconds. Okay, only thing we need to do now is determine how to convert this into degrees. Alright, so 16 revolutions, and remember each revolution is how many degrees? 1 revolution around this circle is 360 degrees. And we have 16 of those. So we need to do 16 times 360 degrees. That gives me 5,760. So it's going to be 5,760 degrees in 2 seconds. 5,760 degrees. So all I'm expecting to see from you are that you have actually written down what I wrote down in the notes. So when I look at your notes, I need to see everything that has been written on this paper in your notes as well. You need this as a reference when you're doing problems in class and when you're doing your homework. So that's my expectation. I do not necessarily expect you to totally have mastered what we've talked about today. That's not realistic. I do expect you to have taken notes on it, and I also expect you to do the quiz in my math lab. It's about 10 questions, and you can also access help in those problems. You can click Help Me Solve This if you need to, and you can click View an Example, and that will talk you through the steps that, however, now granted their explanation may differ from mine slightly every once in a while, but there's no reason why you can't get those problems completed. So we're going to stop here, and we will discuss this when we next meet in class. Thank you.